All right, everyone properly caffeinated? Good. You won't need it. This will excite you. Okay, so I'm going to be talking about two contexts in this talk. One is MOOCs, the other is on campus, so both higher education. And I'm going to be talking about ways in which we can leverage data, in which we have leveraged data, to provide a way to scale personalized guidance in one form or another. And not just prototyped ways in which an analysis could provide for this, but actually created pilots of experiences based on these two analyses. So a little background on both. Of course, that this room is largely aware. Large-scale enrollments in MOOCs, sort of becoming an evolution of the textbook, right? Multimedia textbook. And we also know that access doesn't equal success, right? So just because you can access this course doesn't mean you can cognitively access the course, right? And many people don't, and for a variety of reasons, they leave. Among those reasons is that it's low touch, right? A university experience is one that many students associate with the at least opportunity to have a conversation with their instructor at some point, but that is not really the case in MOOCs for obvious reasons of scale. In higher education, there are also complexities which beg for additional personalization. That's not there. Very high degree complexity. Many course options at UC Berkeley. There's 2,500 courses to choose from every semester. 40% of four-year students at U.S. institutions graduate within 4 years nationwide. And there's about a 1 to 400 student to advisor ratio at four-year institutions. It's worse at two-year public. So in both of these scenarios, there's opportunity for more personalization if we can scale it. In both of these contexts, if you could hire more people, you would. In the MOOC setting, instructors as it is don't really get compensated for doing a MOOC, so you're not going to hire more instructors to do that. In higher education, there have been some initiatives. Gates Foundation has experimented with hiring more campus advisors and have found some benefit to that. But doing it nationwide, there certainly seems to be an opportunity for analytics to help with guidance in these contexts. Okay, so the first context is scaling personal guidance using these data. So these clickstream data from a MOOC, playing video, pausing video, answering questions. This is based on last year's AI Ed presentation on scaling instructor personalization. And so when it comes to instructor personalization in a MOOC, well, we know one-on-one interaction is great, but of course a MOOC experience is very far from that. And so as an instructor of a MOOC, these are my options, let's say from most personalized, which would be that one-on-one effect, versus the least personalized. And on the least end of the spectrum is announcement to an entire class, right? Just the broadcast message, not personalized at all, other than it's to everyone who's in the class. And then on the other end, not on the extreme personalized end, but near there, is individual email exchange, right? That kind of one-on-one asynchronous, or discussion board. All right, so the questions here was not, can we use data to achieve that equivalent of an email exchange or discussion board interaction. I'm sure there are people working on kind of discussion bots, but that's not what this is. Instead, we wanted to see if we could achieve something in the middle, right? So some intermediary level of personalization, some affordance for the instructor. And then if we were able to achieve that analytically, provide an interface for instructors to actually use that and communicate with their students in more personalized ways in a MOOC. And I won't go over all of this, but there's been a lot of work on dropout prediction, both on campus and in MOOCs with different models and so forth, and even frameworks to manage all those models that are being proposed in the literature. It's gotten that far. But this work also was about taking a step back and saying, what good is prediction, right? You say, oh, you can predict this well with this algorithm, with these data, with these features. Okay, now what? And so the paper's also making kind of a call to arms saying, finding usable real-world applications of these models is just as valuable, or should be, to the community as data mining and discovery. Okay, so because of that, the steps in this study were to evaluate the models predictively, just to see what does work, using past literature as a guide, and then to build an analytics backend that could serve these predictions up in real time, download data from edX every day on a automated S3 bucket cron job, and then allow the instructor to not just see these analytics, because that's often where it stops, right? Show the instructor this stuff. Okay, but then what then? You need to also allow them to act and give them some guidance on what that action should look like. And so we add in immediate communication affordance in that dashboard. We use recurrent neural networks to make predictions of dropout, completion, and passing or certification in the class every day. So every day these models produce new predictions of every student's completion, dropout, and certification probability. And the model is somewhat robust because it's trained on 20 courses, which nowadays isn't a lot, but it provided reasonable generalization. So that was about 13 million clickstream events. The blue is the courses we used out of the subset we had. So number of deadlines, we used the ones that had more than one deadline. The one deadline course is self-paced, right? So we did not apply this to self-paced, since the instructor is really at the center of this. Okay, and the short analytic story here is that, yep, the LSTMs and neural networks did pretty well, but what also did pretty well is logistic regression. Okay, so there's logistic regression. So the take home for us was, okay, we proved deep learning is better, but yeah, but if you're weighing the cost of computation and all of this, the models that we're now deploying for use in the pilots are logistic regression models because they do the trick. Okay, who likes live demos? I don't, so I'm not, no, I do. All right, let's do it. Okay. Wow, that's comical. It's not even, okay, well, no idea. I didn't even start the demo. I just exited PowerPoint. All right. Wow. Okay. All right. I'm afraid to touch the computer. Okay, so familiar interface to anybody? Yeah, it's edX. Okay, so this is OpenEdX, and we've written our communicator here in React, which is where edX is moving now. Okay, so this is the analytics from CS169, I think Software as a Service, or Armando's class. And what it's showing here is a histogram of those probabilities of all the students for completion, right? So that means this many students are predicted to complete, this many it's not sure of, this many it's confident will not complete, attrition, certification. So what you can do as an instructor, these are updated every day, is you can say, well, for students who are likely not to get a certificate, but are likely to submit enough materials to complete the class, let me send them a message, right? Right? You know, we're heading into a difficult part of the class. Please let me know if you have any questions. So in this version, you're reaching out to students proactively. This is not a message you'd want to send to everyone, but you're personalizing a message to people who might need help. You're not calling them out on it, but you're reaching out and saying, you can talk to me. Alternatively, if you don't want emails, you could say something like, here are some additional quizzes that students have taken to check their knowledge outside of the class. Okay? And there's any number of ways you can use this, but this becomes another affordance, another way for an instructor to express themselves pedagogically, but at scale. Oh, all right.
I had a quick question, which is, does it provide recommendations to the instructor about what things have been like, or research suggests is effective for the students that are struggling? Like, if you're seeing this class of problems, this might be the right way to how to guide those emails, or maybe that would be next step.
Yeah, so great question. That is next step. So what you just saw is a active pull request to edX. So once it's in there, and this process of signing up to do a pilot with the course is straightforward, right? You don't need months of research preparation to do it. Then we're going to launch a pilot, and if anyone has a course or knows someone who has a course, or you have authority over people who design courses, you're interested in joining this pilot to answer those kind of questions, that's what the pilot's going to be about. Is before we even think about more widely scaling this, do we have a kind of handbook of best practices here? So for example, don't say the algorithm says you're going to fail. Don't do that. And what I have realized is some people don't know that. You know, just as teaching and learning labs or centers of teaching and learning can tell you, not every professor out there knows some obvious things. Okay.
What's interesting about that is whether or not I know it, I have discretion over what I believe.
Yeah. Okay. Any other questions about this context before I move on? All right. tiny.cc/zpUCB. That's my open Google Calendar. Just send an invite. No need to mess around with emails. Okay, so the second context is university courses or university context, and the question here is, can we scale personalized guidance using these kinds of data, right? So I showed before in MOOCs, clickstream data, event logs. Now these are our event logs, the history of courses students took, perhaps with grades added, but essentially it's this kind of data. And when approaching the idea of campus advising, especially at a liberal arts university, forget AI, forget learning analytics, just what do campus advisors think about and what's the value of a liberal arts education, it is part intellectual exploration, right? It's part intellectual exploration, and then it's also don't go so far off the rails that you can't make it to the finish line. You're trying to balance those two things. So when we think about an analytic affordance based on data, we also have to keep in mind that balancing act between those two values. And that worked more smoothly. Okay, so this time I'm going to show you a demo, and then I'm going to talk about how it works. All right, so here's the system deployed at Berkeley. It's linked to by the registrar's office, but that's all the promotion we give to it. So right now it only services about 20% of students every month. So the first feature is more that intellectual exploration, okay? So let's say I'm a sociology student, and I just took a course in my department called Evaluation of Evidence. And Evaluation of Evidence is a course about analyzing data and thinking about the social context of that data. And what the system's doing right now is it's showing you the top 5 matches to that course, which you're naming as your favorite course, so you want a continuation of this idea. And it's showing you the top 5 matches within sociology based on simple course description similarity, right? So making a vector bag of words out of a course description and just saying cosine most similar, not very interesting. This is the more interesting part. Considerations across campus. So here it is mentioning, have you thought about data science connector? Have you thought about introduction to urban data analytics in the city and regional planning department? Have you thought about introduction to ecological data analysis? How about cartographic representation? Problems in the representation of quantitative and qualitative data on thematic maps. Like, wow, that's an awesome data science category that students are not going to type into the old course catalog because they liked evaluation of evidence. So how are we getting these matches? They're not based on catalog description because you would not surface them based on that. All right. Okay, so the answer to how that works, can be found in inspirations taken from natural language processing. So the sequences I gave you at the beginning of this section were enrollment sequences, right? But the most studied type of sequence is this type of sequence, right? Natural language is a sequence, all right? So what has been done in natural language? Well, computer machine learning, recurrent neural networks have been applied to just see if a machine can find a signal in the data, which means can it predict the next word, right? If it can predict the next word, all right, there's some signal. That means the machine has learned some structure of language. Not all that useful, except maybe in a autocomplete on your phone. So the more interesting thing that happened several years after that was to apply an actually simpler model, a linear model, but still a neural network, that embeds words and tries to then learn the relationship between words that you can then query. So you could say things like, France is to Paris as Italy is to, and you're asking the model that, and then it says Rome. Or you can say something like, Microsoft is to Balmer as Google is to, and it says Yahoo, and that was wrong. Okay? So it is not always correct, but it's correct about 61% of the time, and that was from 2013, and it's gotten much better since then. But what's happening here? What's happening when you can do things like king minus man plus woman equals queen? What's happening is it's learning abstractly this semantic of royalty, right? That is a regularity that emerges from these data. And why is that interesting to us? This is how it works. Skip-gram models. I'll skip this for time. That's interesting to us because we want to be able to tell students what are similar courses with respect to their concept, right? Not necessarily with respect to the literal catalog description that's written different ways depending on what department you're in, even if the course is very, very similar. So the innovation here is that the answer is yes. Treating enrollment sequences as if they were sentences, as if they were expressions, communications, works just as well as language. It's almost like the enrollments are kind of a language that lets us understand the meaning of a course by its context. And so this was our data set. It was almost 10 years of enrollment data, 3.6 million enrollments from UCB. This is how many active students every semester, maximum bump in fall, a little dip in spring, and then summers. And undergrads on top, graduates on the bottom, grad students. Okay, so we use that skip-gram model to learn embeddings of courses, and then we kind of explore the semantics. We did have tests to validate and see what accuracies were. We were getting about 41% accuracy. It's now up to 50 on a validation set. But we did things like this. We took a department and then averaged all of its course vectors together to represent the department. And then we said stuff like, we asked it a question. If you had to describe history of art with the combination of two departments, what would it be? And it said art practice plus history. And you see some other interesting kind of face validity things. For example, legal studies is rhetoric plus political science. That's interesting to me. Statistics is demography plus mathematics. Demography is the census. The census plus mathematics is most statistics departments. So there's kind of this face validity stuff. In this paper, it links to the complete n by n combination of all subjects, so you can judge for yourself. Decomposing the space even more, if we say what's the relationship between an arbitrary course and then that department average, you can say things like, well, how mathematical is a particular education course? So here there's education courses and then math courses. And critical studies of education was the least mathematical because it's most to the left there. Mathematics is the x-axis. Differential manifolds is the least education-like class. It's all the way on the right. Sounds hard. And then the highest combination of the two, so at the intersection, was school curriculum 1, 2, and 3 offered by the math department. And so these are a series of 3 courses that cover what is covered in secondary education. And many students who are going into teaching take those. And that is the blend of education and math. So there is some face validity to these semantics. So we also looked to see if we could predict the next course. It does so pretty well about at the peak, around 45% of the semester's enrollments are predicted accurately in the third semester. And we looked at this by department. And this runs a feature in our system that was just very highly demanded by students. They said, yes, we like the exploration, we really do. We find ourselves in kind of groupthink bubbles, in a department. And so they like that explore, but they also want to know how to get out the door. And so we intake graduation requirement rules, and then we cross-list those with the schedule so students can log in, see what requirements they haven't met, select it, and then see the courses that will satisfy that, sorted by their likelihood of taking the class. That's where this predictive model comes in. And if you inspect the model, you get this view of students the semester before they graduate, colored by major, and you see cognitive science students and psychology students at kind of the nexus of the university, where psychology is the entryway to the social sciences and humanities, and cognitive science is the entryway to computer science and STEM. Okay. So to wrap up, these are other applications. You can use this same vector space to predict on-time graduation. We discussed the integration of these models into a system here. And then at LAC 2019, which is next week, we'll be explaining how this space can be used to help guide students through the university based on an objective they have. So I'm a sociology student. I want to do well in machine learning class because I've heard of machine learning. I want to take it. I just don't know how prepared I am. So if I'm not prepared, give me a personalized route to machine learning. Right now, that route is just a single course. Future work will look at sequences. So the concluding slide here is a robot that lives in my department building. This is Berkeley Way West. And it's great. I think it has a name. I forgot its name. But it's very friendly. They have 3 people out in front of it kind of to greet you. So there's more people working here right now. But they're brand ambassadors here to warm you up to really what is one complexion of the future of work, right? So we know that the future of work is uncertain, but we know it's going to change significantly. So one importance for having these kind of personalized affordances that help you dynamically pivot your education with minimum overhead and inefficiencies is this. This is the future, and people are going to want to change their focus and their skill set. Maybe they don't change it to STEM. Maybe they see this and they want to find meaning in the social sciences, right? But in either case, personal guidance is going to be needed. Thanks.
We have about 5 minutes for questions.
I'll follow up on the professors that aren't entirely sure about how to use the communications. Are you monitoring what happens to the students after they receive those emails? And if so, are you looking at the content of those emails?
So we will be looking at the analytics. So how do the analytics change after an email is sent, right? Is there a pivot point in the prediction of, or in the distribution of students completing or dropping out or staying in the, or getting a certificate? So we'll be looking at how those predictions change given an email was sent, and then what are the contents of the emails that change those analytics for the better or worse.
Hi, Zach.
Hey.
I was curious, so in the university setting, the catalog of events is so large, right? And as a student, supply is limited. A supply of time is limited. So have you considered extending this model to, let's say, lectures or other events on campus, and to suggest to students that, hey, you just enjoyed a lecture about XYZ, or when I say lecture, I don't mean a class lecture per se, but just a one-off lecture? That's one question. And the second question is, the granularity here is at the course level, as opposed to at a topic or idea level. Have you considered segmenting it down further? Because it might be that, a student is interested in a certain topic and there's another path there which the current catalog doesn't offer.
Yeah, great questions. In the first case, there's initiatives on campus to create more explorational experiences for students, right? Be that a graduate or any course that leads to research experiences or separate research experience opportunities or internships, something such that when a student leaves, they feel better prepared to take on the world, right? Intellectually, professionally. And so I am thinking about what other sources can be integrated into the data. For example, club information or decals, which are courses students teach to other students. This idea of, oh, you attended a guest lecture kind of thing, what would you need to get that? Because that guest lecture probably didn't have a check-in. You can go into that world of we're monitoring Wi-Fi data. We know you went to that guest lecture. But there's a responsible, boundary there, which Mitchell spoke to, and I have said that my boundary is demographic information. Even though the university has given me access to APIs to access that, I spoke with the technical people saying, I want you to firewall me off from anything about demographics, right? So if the tides turn and people ask, oh, what is the system really doing? They will know. I don't have access to any of that personal stuff, any of that sensitive stuff. So that one will be negotiated, what kind of data. And then your second question was about granularity, yeah. So Sylvia Bunge is a cognitive scientist at Berkeley, and she's interested in having students answer surveys before starting a class. And these surveys are on kind of basic cognitive skills before and after the class. So if we go ahead with that research, we could tag classes with these skills and then generalize them to classes that did not have the survey by way of the embedding, the machine learned embedding. So that's definitely there. We have some research being submitted to EDM that works with that granularity to infer topics that are in the class that weren't being shown in the course catalog.
So Zach, I was going to ask about sort of what we know from Yuri Treisman's work from decades back about the importance of social networks and communities for students who are underrepresented in undergrad, and how it vastly increases their probability of graduation and following specifically, STEM professional pathways. So I recognize why you don't want to use demographic data, but there is this, and probably our friends from Chegg could speak, volumes about all this, but we know that some of that social network is also determined by co-enrollment in courses and things like that to help students feel that they have sources of help and social support. And so just wanted to know more about what you're thinking.
Sure. So a collaborator from UC Irvine, Rachel Baker, is interested in inequities in terms of STEM enrollments and major declaration and so forth. Let me put it this way. If there is a research focus on inequity in particular, I will be happy to then look at demographic data. But I don't want it seeping into the model in ways that I don't anticipate.